Good morning, dear students. Now we can move on to our next topic, that is the compounds of non-transition elements, part 1. And also in that session, we have to discuss these topics, that is manufacture and use of glass, then different types of glass, then silicates, zeolites and silicons. Then coming to borax, there will be boron hydrides, then boron nitrides, borazole and carborine. So this much topic I have to take. Okay. Remaining topics will be taken by other teachers. Okay. So first we can go through the manufacture and use of glass and the different types of glass. Okay. So next is glass. Okay. As you know, this glass, it is a hard and as well as brittle substance. Brittle substance means easily breakable substance. So it is a hard and brittle, and also it is an amorphous, hard, brittle, amorphous, then transparent. Okay. So these are some of the characteristic properties of a glass. It is hard, brittle, amorphous and transparent. Then also this glass, chemically it is the sodium or calcium silicates. It can be sodium or calcium silicates. That is what we call as glass. Okay. And also this, so it can be the transparent silicates of sodium or calcium, and also or it can be of other metals formed by the solidification of the molten mixture. Okay. Formed by the solidification of a molten mixture of this sodium or calcium silicates. Okay. So these are some of the characteristic features. They are hard, brittle, amorphous, transparent. Then glass is usually sodium or calcium silicates, or it can be some other metals formed by the solidification of a molten mixture. And also the composition of the glass, it will be varying. That means it will not be having any definite chemical compound. It will not be having a definite chemical composition. Definite chemical composition, and also it will not be having a definite formula. Okay. Not having a definite formula. Not having a definite formula. And also usually, as you know, it is unaffected by acids as well as bases, isn't it? Unaffected by acids or bases. Unaffected by acids or bases. Then the next one is the preparation of this glass, and for the preparation the raw materials used are the following. Raw materials. The first one, that is silica. Silica, the formula is SiO2. Silica, that is the first one. Then second one, compounds of alkali metals of sodium and potassium. Compounds of alkali metals. Compounds of alkali metals of sodium and potassium, that is the sodium and potassium salt. Okay. For example, normally the sodium potassium salts used are, the first one is, it can be sodium carbonate, then sodium sulfate Na2SO4, then sodium nitrate NaNO3, then potassium carbonate K2CO3, then KNO3. So these are some of the salts used for the preparation. Okay. Then the third one, that is the compounds of alkaline earth metals. Compounds of alkaline earth metals. Compounds of alkaline earth metals of calcium and barium. Okay, that is the third raw material used. So usually for the compounds of calcium and barium used are calcium carbonate. As you all know, calcium carbonate, it is limestone, isn't it? Calcium carbonate, limestone. Then calcium oxide, that is lime. Calcium oxide, that is lime. Then barium carbonate. Barium carbonate, it is usually used for glass with high refractive index. For preparing or for manufacturing glass with high refractive index. For that type of glass, this barium carbonate is used. Okay. So that is the third raw material used, that is compounds of alkaline earth metals of calcium and barium. Then fourth one, that is the oxides of heavy metals. Oxides of heavy metals. That is lead oxide and Pb3O4. Then the fifth one, calcium phosphate, Ca3PO4 twice, calcium phosphate. Then this calcium phosphate, it is used for the manufacture of opalescent glasses. used for the manufacture of opalescent glass. Okay, so these are some of the raw materials. Again, some coloring materials are also used. You know, some glasses are colored, isn't it? So some coloring materials are also used based on the need of the preparation. Coloring materials. Okay, so normally this ferric oxide, it will be giving yellow color. Ferric oxide will gives yellow color to the glass. Then chromic oxide. Chromic oxide, it gives green color. Then MnO2, purple color. MnO2, purple color. Then cobalt oxide, that gives blue color. Cobalt oxide, blue. Then auric chloride, that gives ruby color. Okay, so these are some of the coloring materials used. Ferric oxide, yellow. Chromic oxide gives green. MnO2 gives purple color. Cobalt oxide gives blue. Auric chloride gives ruby. Okay, so these are some of the raw materials used for the manufacture of glass. So the raw materials are, first one is silica, second one compounds of sodium and potassium, third one compounds of calcium and barium, fourth one oxides of heavy metals, lead oxide, then calcium phosphate used in opalescent glasses, then coloring materials. Okay, so these are some of the raw materials used. Then the next one, we can go through the manufacture of ordinary glass. Manufacture of ordinary glass. See, normally this ordinary glass, it is otherwise called as soda glass. Soda glass, it is named otherwise as soda glass, or it can be window glass. Window glass. And also the composition or the chemical name of this ordinary glass is Na2O, then CaO, then 6SiO2. So this is the composition of an ordinary glass or a window glass or a soda glass. Okay. So the first step involved in the manufacture of ordinary glass, that is the fusion of the raw materials. Fusion of raw materials. Fusion of raw materials. See, here the raw materials used are sodium carbonate or sodium sulfate. Sodium carbonate or sodium sulfate, Na2SO4. Then plus mixed with calcium carbonate and silica. Okay, these are some of the raw materials used. Sodium carbonate or sodium sulfate plus calcium carbonate plus silica. So these raw materials, they are finely powdered. These raw materials are finely powdered and then it is mixed. Finely powdered and then it is mixed with one another. And also after mixing properly, it is mixed with a small amount of scrap glass. Okay. It is mixed with a small amount of scrap glass, and this scrap glass will act as a flux. Okay. Normally, you know, flux plus gangue gives slag, isn't it? Flux plus gangue gives slag. So here this scrap glass acts as the flux. Then this mixture, it is fused in a furnace using producer gas. Okay. Then the mixture, it is fused together, fused in a furnace. The mixture is fused in a furnace using producer gas. Using producer gas. Okay. So now we have to go through the equation. That is the first raw material, that is sodium sulfate. It can be sodium sulfate or sodium carbonate. So sodium sulfate plus silica 2SiO2 plus carbon giving 2Na2SiO3. Sodium silicate plus CO2 plus 2SO2. Okay. Then the next reaction, sodium silicate Na2SiO3 plus calcium carbonate CaCO3 plus 5SiO2 giving Na2O CaO 6SiO2 plus CO2. Okay. So this Na2O CaO 6SiO2, that is the window glass or the ordinary glass. Okay. So here, see, one of the byproduct is carbon dioxide, isn't it? So due to the formation of carbon dioxide, what happens is that frothing will be there. Okay. Froths will be developed. due to the formation of this carbon dioxide. So what happens is that in order to remove carbon dioxide, as you know, this carbon dioxide can be removed by further heating. So the froth will be removed by further heating. That is, by heating, this carbon dioxide gas will be escaped. Okay, it will be expelled out, and we will be having, after this heating, so the froth will be completely removed. After this heating, we will be having a viscous fused mass. A viscous fused mass will be obtained. So that is the first step, fusion of the raw materials. So this raw materials, they are mixed together, they are finely powdered and then mixed together, then mixed with a small amount of scrap glass, then fused in a furnace along with producer gas. Then you have to write down the equation. In the first step, sodium silicate is formed, and in the second step, glass is obtained. Then along with that, carbon dioxide will be there. This carbon dioxide, due to the presence of this carbon dioxide, a froth will be developed, and this froth is removed by heating, and then we will be having a fused mass. Okay, so that is the first step. Then the second one, that is the working of molten glass. Okay, working of molten glass. Working of molten glass. See, from the previous step, we had got a fused mass. So this fused mass, it is then poured into suitable mold. As you know, mold, isn't it? So whatever shape we require, we have to put it into that particular mold. And so while transferring it to suitable mold, we can shape that particular glass into our need. That is, it can be in the form of bottles or flask, etc. So suitable molds are used for this process. And also then it is, after transferring it into the molds, it is then allowed to cooled gradually. Okay, it's allowed to cooled. So that is the second step. It is allowed to cool gradually. Then this is the second step, that is the working of molten glass, that is using molds. We are using certain molds depending upon our need. Okay, then the third one, the third step, that is annealing. Third step, that is annealing. Annealing. See, normally what happens is that if the glass is cooled rapidly, if the glass is cooled so fast, what happens is that it will be leading to brittle. It will leads to brittleness of that particular glass. Brittle means it will be easily fragile, brittle and also fragile. Okay, the glass is cooled rapidly, it becomes brittle as well as fragile. And if the glass is cooled slowly, if the glass is cooled slowly, then it becomes opaque. Okay, then the glass becomes opaque. So normally in this, normally in some glasses we doesn't need such type of glasses, that is brittle glass or opaque glass. Okay, so for that we will be the articles or this glass will be cooled neither rapidly nor slowly. Okay, that is, the cooling process should be in between. It should not be cooled neither rapidly nor slowly. That means the cooling process will be in between these two. Okay, so for that what we are doing is that the glass, the fused mass, it is the molded mass, it will be then passed through a furnace. Okay, the molded mass will be passing through a furnace, and the furnace, it will be like this. At the mouth end of the furnace, if this is the mouth end of the furnace, it will be very hot at this portion. The mouth end will be very hot, and the tail end will be at room temperature. Okay, so the furnace, while passing this glass through a furnace, the furnace will be sophisticated like that. That is, the mouth end will be very hot and the tail end will be room temperature. So that what happens is that when the glass, when the article, it is cooled gradually through this tunnel. Okay, this is a tunnel, and when the glass particle, it is passed through this tunnel, what happens? It will be slowly cooled. Okay, while passing through this passage, and this process of cooling of this glass, it is called as annealing. This process is called as annealing. That means the glass is neither cooled rapidly nor slowly. The mouth end will be very hot and the tail end will be at room temperature, and the articles will be passed through this furnace. While passing through this tunnel, it will be gradually cooled. So the process is called as annealing. Okay, so this process, it will be taking several days for completion also. So this is regarding the manufacture of the glass material. Okay, manufacture of the glass. Then we can go through the types of glass. So this manufacture involves 3 steps mainly. The first one, that is the fusion of raw materials. Second one, working of molten glass, and the third one, that is annealing. Okay. Then the next is types of glass. These portions are very, very important. It will be asked in your examinations. Types of glass also it will be asked. The manufacture also will be asked sometimes. So types of glass, the first category, that is the soda glass. Soda glass. Soda glass, or otherwise it is called as ordinary glass. Ordinary glass or soft glass. Soda glass, ordinary glass or soft glass. Okay. So this soda glass, the composition, it is like this. Silica SiO2, it is about 75%. Then sodium oxide Na2O, sodium oxide 15%. Then calcium oxide, it is 8%. Then aluminium oxide or alumina Al2O3, alumina, it is about 2%. Okay, so this is the composition of ordinary glass or soft glass or soda glass. Okay, and also normally this ordinary glass, it softens at low temperature. And also some of the uses for this ordinary glass. Uses, normally it is used for making window glass. Window glass, then bottles, then dishes, etc. Okay, so that is the purpose of ordinary glass. So this is the composition and use. Okay, you have to go through both these. Then the second type of glass, that is the potash glass or hard glass. Potash glass or hard glass. See, in the ordinary glass we are using sodium carbonate, isn't it? So instead of sodium carbonate, for manufacturing potash glass we have to use potassium carbonate. Okay, instead of sodium carbonate we are using potassium carbonate, so that we will be obtaining potash glass or hard glass. And also some of the characteristic features of this potash glass are, it has got high melting point, and also it can withstand high temperature. High melting point, and it can withstand high temperature. And also it is used for, uses means it is used for hard glass apparatus. It is used for making hard glass apparatus. Okay. So that is the case of potash glass or hard glass, just replacing sodium carbonate with potassium carbonate. Okay. Then the next one, that is the flint glass or lead potassium lime glass. Third one. Third one, that is the flint glass. Flint glass or lead potash lime glass. Lead potash lime glass. So here the raw materials used for the manufacture of this flint glass are the composition, it is silica, it is about 45%. Then sodium oxide Na2O, it is 4%. Then potassium oxide K2O 4%. Then calcium oxide 3%. Calcium oxide 3%. Then lead oxide PbO2, it is 44%. Okay, so this is the composition of flint glass or potash lime glass. And also some of the characteristic features of this flint glass are, they have got high density and high transparency. High density and high transparency. High density and high transparency. Then again, it has got high refractive index. High refractive index. Then the third one, the use of this flint glass or lead potash is, it is used for making prisms. You have seen prisms and lenses, no? So it is used for making prisms, lenses, etc. and also for ornamental purposes. Used for ornamental purposes. Okay, so this is about flint glass. Silica 45%, sodium oxide 4, then potassium oxide 4%, calcium oxide 3%, lead dioxide 44%. And also the characteristic features are high density, high transparency, high refractive index. Then uses of this are used for making prisms and lenses and also for ornamental purposes. Then the next one, the fourth type of glass, that is the Jena glass. Jena glass, Jena, Jena glass. So this Jena glass, the composition is, it is a mixture of zinc and barium borosilicates. It's a mixture of zinc and barium borosilicates. Okay, zinc and barium borosilicates. And also one of the characteristic feature or the strongest feature is that it is stronger than ordinary glass. Okay, stronger than ordinary glass, and also more resistant to acids and alkalis. More resistant to acids and alkalis. That is the characteristic features of this Jena glass. Okay. And also one more point is there. It has got a low coefficient of expansion. Low coefficient of expansion. So these are the properties of Jena glass. Then the next one, the fifth category, that is the Pyrex glass. Pyrex glass. So here this Pyrex glass, it is a mixture of sodium aluminium borosilicate. It is a mixture of sodium aluminium borosilicate. Sodium aluminium borosilicate, that is Pyrex glass. Okay, and also regarding the composition, silica is about 80%. Silica 80%. Sodium oxide, it is 4%. Then calcium oxide, it is 0.5%. Then potassium oxide, again 0.5%. Then B2O3. Boric oxide, it is 12%. Then alumina, it is 3%. Okay. So this is the composition of this Pyrex glass. Silica, sodium oxide, calcium oxide, potassium oxide, then boric oxide, then alumina. Okay. Then next one, some the characteristic features of this Pyrex glass. Here also the coefficient of expansion, it is low for Pyrex glass. Coefficient of expansion, it is low for Pyrex glass, and also it can withstand sudden changes in temperature. It can withstand sudden changes in temperature. It can withstand sudden changes in temperature. And also the uses of this Pyrex glass are, it is used for making laboratory glasswares. Used for making laboratory glassware. See, in laboratory glasswares, we are heating the substances using glass apparatus, isn't it? So there we are using this Pyrex glass. Okay. So laboratory glasswares, normally beakers, etc. Beakers, flask, etc. are made up of this Pyrex glass. Then the next one, the sixth one, that is the crown glass. Crown glass. So here crown glass means in the case of soda glass we are using silica. So instead of silica, a partial replacement of silica by phosphorus pentoxide, P2O5, it is partially replaced. Silica partially replaced by P2O5. Silica partially replaced by P2O5. That gives the crown glass. Silica, that is in the case of soda glass. In the composition of soda glass, silica is partially replaced by P2O5. That gives the crown glass. That is the sixth one. Then the seventh one, that is the safety glass. Safety glass or shatterproof glass. Safety glass or shatterproof glass. So here this safety glass, it is prepared by using two layers of glass, that is 2 layers of glass are there, and in between a transparent plastic will be placed. So if this is the 2 layers of glass, in between a transparent plastic will be placed. A transparent plastic will be placed in between 2 layers of glass. Okay, so normally this transparent plastic used is vinyl acetate resin. Vinyl acetate resin, that is the transparent plastic used in between, and this resin or this transparent plastic, it acts as an adhesive. Okay, it will be acting as an adhesive. That means it will be joining the 2 layers of the glass. Okay, it will help to join the 2 layers of glass, and this will be acting as an adhesive. And also, so in total we can say that there will be 3 layers, isn't it? So these 3 layers are joined or hold tightly by applying some amount of heat as well as some amount of pressure. Okay, by applying heat and pressure, these 2 layers are joined with the help of this transparent plastic, that is vinyl acetate resin, that acts as an adhesive here. And also, normally this glass will not break easily. Okay, by any ordinary situations, means it will be prepared by, or it is manufactured by applying heat as well as pressure, and also 2 layers are there in between, and adhesive is there, isn't it? So a normal impact cannot break this glass. That is why it is used as a safety glass or a shatterproof glass. And normally it is used in automobile windshields. Normally it will be used in automobile windshields, then goggles, etc. Automobile windshields, goggles, etc. Then the next one, the 8th one, that is bottle glass. Bottle glass. So here this bottle glass means ordinary soda lime glass, along with that composition, it will be having 3.5% magnesium oxide and again 0.5% alumina and mixed with Fe2O3, ferric oxide. Okay, so along with the composition of ordinary soda lime glass or ordinary glass, along with the composition of ordinary glass, it is mixed with 3.5% magnesium oxide and 0.5% alumina or Fe2O3. And also bottle glass, it is used for making bottles. For making bottles. Okay, that is the 8th type of glass, that is the bottle glass. Then the next one, the 9th one, that is the fiber glass. Fiber glass. See here, fiber glass, it is a molten glass. Okay, molten glass. Fiber glass is a molten glass, and also it is processed to a flexible thread. Molten glass which is processed to a flexible thread of filament. That is the fiber glass. And also it is not brittle. Not brittle. Then it has got high tensile strength. High tensile strength. Not brittle, high tensile strength. Then and also those fabrics which are made of fiber glass, it's a bad conductor of heat and electricity. Bad conductor of heat and electricity. Bad conductor of heat and electricity, and also they are non-flammable. Sorry, non-inflammable. Non-inflammable. Okay, so one characteristic feature of this fiber glass is that they are fireproof. Okay, they are fireproof. Since it is non-inflammable, they are fireproof. So these are some of the characteristics of fiber glass. Then next one, going to the next type of glass, that is the quartz glass. Quartz glass or silica glass. Quartz glass or silica glass. See, this quartz glass, it is obtained from pure silica, pure SiO2, okay, obtained from pure silica, and again it has got a low coefficient of expansion, then it does not break when plunged into water, That is another feature. That is when it is heated to red hot and when it is put into water, what happens, or when it is plunged into water, it will not break. Okay. Does not break when plunged into hot water. When plunged into hot water. Sorry, plunged into water while red hot. Then the next one. The last point, that is it is used for making crucibles. Normally crucibles, sometimes you may know crucibles, it can withstand a very high temperature. Okay, so this crucible, it is made up of pure silica. So that is about quartz glass or silica glass. It is made from pure silica, has got low coefficient of expansion, does not break when plunged into water while red hot, then used for making crucibles. Then the next one, the 11th one, that is the ground glass. Ground glass. See, ground glass means normally the rough surface, it is ground glass. Now it is a soft glass. Okay, that means the rough surface, it is ground by the process called as sandblasting. Sandblasting, it is a process. Sandblasting, it is a process by which this rough surface, they are smoothened. Okay, rough surface are smoothened by means of high pressure. A high pressure is applied to smoothen the rough surface. That process, it is called as sandblasting. Okay, and also this ground glass, it is a soft glass, and also it is ground by using turpentine or emery, or by sandblasting. Okay, so by this process it is prepared. This ground glass is prepared. Okay. Then the next one, the 12th one, that is Crookes glass. Crookes glass. Crookes glass, this is another type of optical glass. Crookes glass, it is a type of optical glass, and also it contains cerium oxide, CeO2. Okay, it contains cerium oxide, and here the oxidation state of cerium, it is +4, isn't it? So it is a special type of optical glass, and also it contains cerium oxide, and also it will be it will cut the harmful UV rays and will protect our eyes. Okay, cut the harmful UV rays and protects our eyes from sunlight. Okay, and therefore it is this Crookes glass, it is used in sunglasses. So the composition of in sunglass, one component is cerium oxide. Okay, so that is an optical glass, and also it cuts the harmful UV rays from damaging our eyes, and it protects us from sunlight. So it is used in sunglasses. Okay, so this much is about the different types of glass. You had got 12 types of glass, and you have to study the composition, then characteristic features, and the uses of all these glasses. It may sometimes be asked in a part of essay. Okay, I think in the last year it is asked, I think so. Then you have to study this also, and also I will be uploading the notes in your Google Classroom as well. Okay, so thank you.